In this session, we will interface different type of motors with the Arduino Uno board, and I will show you how to connect the motor and drive it from your board. So there are different type of motors, right? DC motor, servo motor, stepper motor. So first we are going to see DC motor. So this is DC motor. So a DC motor or direct current motor is the most common type of motor. It normally have just two leads, this one and this one. One is positive and another one is negative. If you connect these two leads directly to your battery, the motor will rotate. If you switch the leads, the motor will rotate in opposite direction. So how to control a DC motor? To have complete control over DC motor, we have to control its speed and rotation direction. This can be achieved by combining these two techniques. One is pulse width modulation to control the speed and another one is Hutch bridge to control the rotation direction. So first pulse width modulation to control the speed. We have already seen this pulse width modulation in last session, right? So the speed of a DC motor can be controlled by changing its input voltage. So a common technique to do this is to use pulse width modulation. It is a technique where the average value of the input voltage is adjusted by sending a series of on-off pulses. The average voltage is proportional to the width of the pulses known as the duty cycle. The higher the duty cycle, the higher the average voltage applied to the DC motor, and the shorter the duty cycle, the lower the average voltage applied to the DC motor. So next, Hutch bridge. So what is Hutch bridge? The spinning direction of a DC motor can be controlled by changing the polarity of its input voltage. A common technique for doing this is to use a Hutch bridge. And Hutch bridge consists of 4 switches S1, S2, S3 and S4 with the motor in the center forming an Hutch-like arrangement. Closing 2 specific switches in a time reverses the polarity of the voltage applied to the motor. This causes a changing in the spinning direction of the motor. So, and now the important thing is that we should not drive the motor directly from Arduino board pins. This may damage the board. We have to use a driver circuit or an IC. So this is the IC we are going to use, L293D IC. The motor driver is a module for motors that allows you to control the working speed and direction of 2 motors simultaneously. This motor driver is designed and developed based on L293D IC. So it is a 16-pin motor driver IC. This is designed to provide bidirectional drive currents at voltage from 5 volt to 36 volt. So let's see the pin out. So it is a 16-pin IC with 8 pins on each side. Here is 8 and here is the another 8 to controlling the 2 DC motors simultaneously. There are 4 inputs, 4 output pins and 2 enable pins for each motor. So first power pin VCC1 and VCC2. So this motor driver IC actually has 2 input powers. VCC2 here. Pin gives power to the internal Hutch bridge of the IC to drive the motors. You can connect an input voltage anywhere between 4.5 to or something 36 volt to this pin. And coming to VCC1 is used to drive the internal logic circuitry, which should be 5 volt. And then coming to ground, there is 4 ground pins on this IC. Common ground pins, all 4 ground pins are internally connected and used to dissipate the heat generator under high load conditions. And then coming to output pins, there are 4, output 1, 2, 3 and 4. So the L293D motor driver's output channel for a motor A and B are brought out to pins output 1, 2 and 3, 4 respectively. You can connect 5 to 36 volt DC motor to these pins. Each channel on the IC can deliver up to 600 mA to the DC motor. However, the amount of current supplied to the motor depends on system's power supply. And then coming to direction control pins, there is nothing but input pins, input 1, 2, 3 and 4. By using these direction control pins, you can control whether the motor rotates forward or backward. So these pins actually control the switches of the hatch bridge circuit inside the L293D IC. The IC has two direction control pins for each channel. The input 1 and input 2 pins control the spinning direction of motor A, while input 3 and 4 control the spinning direction of motor B. The spinning direction of a motor can be controlled by applying logic high, which is 5 volt, or logic low, which is ground, to these pins. Then speed control pins, which is nothing but enable pins. The speed control pins enable 1, 2 and enable 3, 4 are used to turn on or off the motors and control its speed. Pulling these pins high will cause the motors to spin, while pulling it low will stop them. But with pulse width modulation, you can actually control the speed of the motors. Now let's write the code. Open your software IDE. Okay, let us write the code first. I'm just going to make it fresh. So first, I'm going to mention the pins. So first, pulse width modulation pin is, let it give 2, and constant integer. Then input pin, let assume 8, and constant integer. Input second pin is, let's take 9, and then inside void setup I'm going to mention model pin. So first, pulse width modulation as output, and then input first pin is same output, and then pin mode input second is also output. So now inside void loop, first I am going to spin my motor in clockwise direction. So for that we have to do is make digital read command. Inside I'm gonna make input 1 pin is first high, and then make the second pin as low. So first input pin is high and second input pin will low. Will make your motor rotate in clockwise direction. Then let's just mention pulse width modulation. So inside pulse width modulation, let's give the maximum value 255. Speed, I'm mentioning speed here. So setting pulse width modulation of the motor to 255, we can change the speed of rotation by changing pulse width modulation input. But we are only using Arduino, so we are using highest value to drag the motor. Then I'm going to give a delay for like 3 seconds, and now I'm going to break my motor. I'm going to just make first pin is high, second pin is also high, will make your motor break. 2 is also high. Then give a delay like for 1 second. Let's give 1 second. Now let's rotate in anti-clockwise. So for that, make opposite. Just give one is first make it low, then make it high, the second pin. So second pin is high, and then give a delay for like 1000. So first, this is for clockwise direction, and second one is for break, and this is for anti-clockwise, and then again I am going to break my motor. For that, make high, high and delay of, let's give 1 second. So here I gave 3000, so here also I'm going to make it as 3000. So let me check it first. Make sure that your board is connected and the correct port is connected or not. So here I'm selected Arduino Uno board and then component 3. Let's verify it. Yeah, our code is error free. Now let's jump into hardware part. Yeah. These are the components which we need for DC motor control. So for what we are needing, breadboard, Arduino Uno, DC motor and L293D IC. Let me connect it first. So first open the pin diagram. Let me open this. Yeah. So using this, you will make a connection first. First ground your circuit. Wait. So let me take commonly here. I'm going to ground it. Using this. The center one, yeah, this. And similarly like this side. Okay, now let's connect the power. So take a common power here. And now give one end of the power here. So the first pin. Now this 8 pin. Now give the second pin to pulse width modulation. Pulse width is enable pin. So first pin, connect second pin to enable. Now let's give input and output. So input pin is second pin. And 7th pin here. So make this two. One is 8 and another one is 9, right? So now let's give the output pin. Third pin and 6th pin is the output pin. So third pin is here. I already uploaded the code first. So if you are uploading your code into your hardware, in the sense it will run like this: forward direction and now in reverse direction. It will spin continuously until your board got powered off. This is the output. So now let's see the next motor, which is, this is the right time to switch your masterclass into certified internship. So in this 1 month internship, you will get 90 days access to complete records. You will get internship certificate and you can download all the presentations.
You will get 8 plus project source code, and for every week there is a mastermind session. You can clear your queries and doubts with your mentor, and there's a particular group for internship members, and you will get access to Pantech community and as well as career guidance sessions. So in this internship we have include some projects. Let's see what it is. Soil moisture control, smart street light monitoring, water quality monitoring, smart parking using Arduino, health monitoring, smart circuit breaker using Arduino, ATM security using Arduino, vehicle speed controller, and surveillance systems using Arduino.
Servo motor. So first, servos are motors that allow you to precisely control physical movement because they generally move to a position rather than continuously rotating. They are simple to connect and control because the motor driver is built right into them. So, the servo contains a small DC motor connected to the output shaft through gears. You can see here, right? The output shaft drives a servo arm and is also linked to the potentiometer. So the potentiometer provides position feedback to the error amplifier in the control unit, which compares the current position of the motor to the target position. In response to the error, the control unit adjusts the motor's current position so that it matches the desired position. So how do servo motor works? You can control the servo motor by sending a series of pulses to it. A typical servo motor expects the pulse every 20 milliseconds. So here, that is, the signal should be 50 Hz. The length of the pulse determines the position of the servo motor. A short pulse of 1 millisecond or less will rotate the servo to 0 degrees. A pulse duration of 1.5 millisecond will rotate the servo to 90 degrees. A pulse duration of 2 millisecond or so will rotate the servo to 180 degrees. So this is how it works. Pulse ranging from 1 millisecond to 2 millisecond will rotate the servo to the position proportional to the pulse width. Okay. Let me describe the servo motor spin out. So it's the 3-wire terminal. One is ground, power and control. So ground serves a common ground for the motor and the logic, and the power is a positive voltage that powers the servo, and control is an input for the control system. So now let's build the code. Okay, let me write the code first. Let me erase it. And before writing the code, make sure that you have to install libraries. So go to include library, manage libraries. Let's just type servo. I have already installed it. If you are not installed it, go and install it. Servo by Michael Margolis Arduino. Okay. Now let me write the code. First, I have to include servo. So servo dot hash library includer. Then I'm going to mention potentiometer pin. This is analog, right? So I'm going to take A0 and servo pin. Servo pin, let me take like 9. And now I'm going to create an object called servo. Now inside void setup, let me attach servo pin. So servo dot attach of servo pin, and then now coming to void loop. Here I am going to read the pot pin's value, and I am going to store it in a variable. So int, I am going to read it, right? So reading, right? I am going to read pot pin, and I am going to store the value in the reading variable. And now I am going to map potentiometer and servo. So the analog read function returns the value between 0 and 1023, right? However, we must scale it down because the servo can only rotate 180 degrees. One method is to use the Arduino map function, which remaps the number from one range to another. So, what we have to give is, let me take like angle. Inside I'm going to map reading. Analog resolution is 0,1023 and potentiometer, the degree is 0 to 180, right? So that's it. We are mapping. Then I'm going to write the angle. Yeah. Now let me verify it first. Our program is error free. Now let's move to hardware part. So these are the components which we are needed for servo motor connection: breadboard, Arduino Uno, jumper wires, potentiometer, and servo motor. So let me connect it first. There are 3 pins in your servo motor, right? So the ground pin is for ground, and the red pin is for power, and the orange pin is for pin. So 9 we have taken. So now coming to potentiometer, make one end is ground and the other end is connected to power, and the center one is connected to A0. So let me boot it first. Now, just by adjusting your potentiometer, your servo motor will run like this. So, you can set your servo motor at a particular degree, whichever you want or whatever you want. So, this is our output.
So now we are going to talk about 28BYJ48 stepper motor with ULN2003 driver. So we are surrounded by stepper motors without even realizing it, as they are used in so many everyday items including window blinds, 3D printers, DVD players, security cameras and CNC machines. We are a lot closer to stepper motors than you think. Stepper motors fall somewhere between a conventional DC motor and a servo motor. They can rotate continuously like DC motors and be positioned precisely like servo motors, in discrete steps. If you are just getting started with stepper motor, so this is the great choice. They typically come with ULN2003 based driver board, making them very simple to use. So now, do you know how the stepper motor works? So stepper motor uses a cogged wheel and electromagnets to nudge the wheel round a step at a time. Each high pulse set energizes the coil, attracting the teeth closest to the cogged wheel and rotating the motor in precise and fixed angle increment, which is known as steps. So the number of steps that the stepper motor has in a 360-degree rotation is actually the number of teeth on the cog. So the way you pulse these coil determines how the motor operates. So the sequence of pulses determines the spinning direction of the motor. The frequency of the pulses determines the speed of the motor. The number of pulses determines how far the motor will turn. By energizing these coils in the correct sequence, the motor is rotated. So now let's see the 28BYJ48 stepper motor. So it is a 5-wire unipolar stepper motor that runs on 5 volt. It's perfect for projects that require precise positioning like opening and closing a vent. Because the motor doesn't use contact brushes, it has a relatively precise movement and it's quite reliable. The only drawback is that it is somewhat power hungry and consumes energy even when it is stationary mode. So now let's see the pinout of this particular motor. Okay, so it has 2 coils, each of which has a center tap. these two center taps are connected internally and brought out the fifth wire, I mean this red wire. So together, one end of the coil and the center tap from the like a phase, thus it has a total of 4 phases. So the red wire is always pulled high. So when the other lead is pulled low, the phase is energized. So the stepper motor rotates only when the phases are energized in a logical sequence, which is known as a step sequence. Now let's talk about that particular driver, which is ULN2003. Because this stepper motor consumes a significant amount of power, it cannot be controlled directly by a microcontroller such as Arduino. To control the motor, a driver IC such as ULN2003 is required. Therefore, this motor typically comes with this driver board. So, the ULN2003, known for its high current and high voltage capability, it provides a higher current gain than a single transistor and allows a microcontroller's low voltage, low current output to drive a high current stepper motor. So, it consists of an array of 7 Darlington transistor pairs, each of which can drive a load of up to like 500 milliampere and 50 volt. So, this board utilizes 4 of the 7 pairs. So, the board has 4 control inputs and a power supply connection. Additionally, there is a Molex connector that is compatible with the connector on the motor, allowing you to plug and motor directly into it. So, the board includes 4 LEDs that indicate activity on the 4 control input lines. So, they provide a good visual indication while stepping. There is a on-off jumper on the board for disabling the stepper motor if needed. So, now let's talk about this board pin out. So see, from input 1 to input 4, these are motor control input pins. We can connect them to the Arduino's digital output pins and ground pin, and VCC pin, it powers the motor and motor connector. So this is where the motor plugs in. The connector is keyed, so it will only go in one way. So now we can go for programming part. Let me open Arduino IDE. So see, we will use the Arduino stepper library which comes with the Arduino IDE. So the Arduino stepper library handles the stepping sequence and allows you to control a wide range of unipolar and bipolar stepper motor. So let's start with including library. So here I am going to give like stepper.h, and now I am going to define the number of steps per rotation. For that I am going to take constant integer steps per revolution, which is equal to, I am going to give like 2038. So here a constant named steps per revolution is declared and assigned the value 2038. So this value represents the number of steps the stepper motor needs to complete in one full revolution. Now let's create an instance of stepper class. I'm going to give stepper. I'm going to name it like my stepper, which is equal to stepper. Inside I'm going to pass argument as this steps per revolution, and as well as I'm going to mention the pin names, pin number 8, 10, 9 and 11. So an instance of the stepper class named myStepper is created. The constructor of the stepper class is called with parameters, steps per revolution, and here the pins entered in the sequence, like this is for input 1, this is for input 3, this is for input 2, this is for input 4. That's why I gave like 8, 10, 9, 11. So for proper step sequence. And then inside void setup there is nothing to do because stepper library sets pin as output, right? We can directly go for void loop function. Okay, here let's write statements for clockwise rotation of the motor. So using my stepper dot set speed function, inside I'm going to pass argument as 5. So this line set the speed of the stepper motor to 5 revolutions per minute using this set speed method from the stepper library. Now let's try to rotate the stepper motor by 1 full revolution in the clockwise direction. So my stepper dot step, inside we need to pass steps per revolution. So here the stepper motor is instructed to take a step equal to the number of steps per revolution in the clockwise direction, and we can go for a delay, just 1 second is enough. Now it's for counterclockwise. Let's set the speed to 10 rpm, 10 revolution per minute. So my stepper dot set speed, inside I'm going to pass 10 rpm. Now my stepper dot step, inside I'm going to give like minus steps per revolution. See, the stepper motor is instructed to take a step equal to the number of steps per revolution in the counterclockwise direction. The negative sign before this steps per revolution indicates that opposite direction compared to the previous rotation. And now we can go for a delay, just 1 second. That's it. Now we can move to the hardware part. Okay, now we have all the components. Here is our Arduino Uno, here is our stepper motor, and here is our driver. We just need to connect all these pins to the driver like this. So now let's connect the input pins with Arduino's digital output pins. First, input 1 pin has to be connected with pin number 8. And input 2 has to be connected with 9. And 3 has to be connected with 10. And 4 has to be connected with 11. And here we need to connect ground, and at last we need to provide 5 volt. Our connection. Now let's upload the code and see the output. Before that, let me connect my Arduino Uno to my PC. Now let me upload this code. Integer, right? Okay. It's uploaded. Here see, it's slowly rotating. Now clockwise direction. Now in anti-clockwise direction. According to we set our speed. So this is our output. You can also see the LEDs blinking like this according to the rotation. So now the motor is rotating full speed. So the LED is blinking like this. If it is slow down the sense, the LED will also will be dimming. So see, now we are going to write another program using Axel stepper library. Here we will use an advanced stepper motor library, which is the Axel stepper library. It outperforms the standard Arduino stepper library in the following ways. Like it supports acceleration and deceleration. It supports half step driving. It supports multiple steppers at once with independent concurrent stepping on each stepper. So this library is not included with the Arduino IDE. So we need to install it. For that, go to Sketch, include library, manage library, search like Axel Stepper by Microcontroller, right? Something. I have already installed this. If you are not having this instance, you can go and install this. Okay, so now let's write the code. First, as usual, we need to include the library, include Axel Stepper.h, and then I'm going to define step constant like motor interface type. I want to take 4. So this line defines a constant name motor interface type with the value 4, indicating that the motor interface type for the Axel Stepper library. Now let's create an instance. So Axel Stepper, I'm going to create like my stepper. So inside we need to pass this motor interface type and as well as the pin numbers. The same connection which we used in previous program. So the same connection and same pin number. Okay. So now the constructor of the Axel Stepper class is called with parameters like motor interface type and the pin numbers in the sequence like 1, 3, 2 and 4. So inside void setup function, let's set the maximum speed and acceleration factor, initial speed and the target position. So using my stepper dot set max speed, I'm going to pass 1000.0. So this line set how fast the motor can go. You can change this number to make the motor move faster or slower. And again, my stepper dot set acceleration, I'm going to pass 50.0. So this line decides how quickly the motor speeds up and slow down. The number 50 means it will take some time for the motor to reach its maximum speed or stop. You can also adjust this number to control how smoothly the motor accelerates and decelerates. Okay. And now my stepper dot set speed. I'm going to set speed like 200. So this line set the initial speed of the motor when it starts moving. So the number 200 means the motor will start at a speed of 200 steps per second. Now, my stepper dot move to inside 2038. So this line tells the motor to move to a specific position and 2038 is the target position in terms of steps. The exact number depends on how your system is set up and how far you want the motor to move. Now we can go for loop function. So now let's write a if condition to change direction once the motor reaches its target position. So if my stepper dot distance to go, compare it to 0. Here my stepper dot move to inside minus my stepper dot current position. So this condition check if the motor has reached the target position. If the motor has reached the target position, it changes the direction by moving to the negative of the current position. And now my stepper dot run. So this line moves the motor one step. The run function is called continuously control the motor with acceleration and deceleration. So now let's upload this code and we'll see the output. Okay. Yeah, it's uploaded. So now see. Slowly turn off. Now in anti-clockwise rotation. So using this LED we can able to know the speed of the motor. So it's running the full speed now, it is off state. See? This is our output. And this 1 month internship is just $699. Use this link to make your payment. And also there is 3-month internship on embedded system. The lines up are Arduino programming, Raspberry Pi programming, Internet of Things and PCB designing. This is for 1299. And in this 3-month internship you will get 360 days access to complete records and 3 certificates. You can download all the presentations. You will get 18 plus project source codes and every week you will have mastermind session. There is a particular group for internship members and you will get access to Pantech community as well as career guidance session. So this 3-month internship is for 1299. Use this link to make your payment. If you have